Okay, I want to start this off. Most of you know me, John Bedini. This is a Flash Forge Creator Pro, this machine. And so I wanted to show you, I just built this 5.5 inch monopole wheel. And the simplified 3D program actually draws it out while you're printing it so you can watch what it's doing. It's got a very unique slicing engine in it that works pretty well. So let's go over to and see what it printed. Okay. This is a replication of the Ferris wheel which I showed at the convention, with one exception, which I'm going to point out. It does not have the mass weight. Of course, everybody knows that. And it's 3D printed. It's using 7 magnets on the outer perimeter and 3 coils at the bottom. Now, the center coil here is North Pole, and that's at the top. And the 2 outer ones are South Pole, and there's a reason for that. Is that in this type of arrangement here, we can actually get a pull with the push depending on where we put this reed over here. Right now it's just pushing. So, and the reason for the fan blade is to keep it stable when it's rotating at fast RPM. Right now it's running at its minimum, and so I consider this a pusher motor. It's in repulsion, and the magnets are all North Poles around the outer perimeter, and it's running at the lowest power that it can run at, which is 3 volts at 1 milliamp, and that's due to the friction on the bearings, and that's the only reason. Otherwise, if it was on needlepoint bearings, it would be in the 2 to 5 microamp level. And so let's have a look at the scope, and you can see what the waveform looks like with 3 poles. So as you can see the reeds switching on and off here, and the high voltage spike, or the radiant, that's generated from the top. So this is running at 3 volts, and these spikes are, this is on the ×10 probe. So these are 5. The spikes are about 10, maybe 11 volts above the normal voltage, sometimes exceeding much higher depending on how the reed opens and closes. So it's really not what I would consider real stable operation with the reed. Dad have released a circuit with 2 transistor, and so did lid motor, but unfortunately that's not going to work with this, and there is some difficulty in building that circuit. So you can try it if you want, but the reed's the best operation with this so far, unless you want to go into Hall or optical switching. So let's have a look at it again, and then we're going to go over and look at the models. Here you can get a better look at where the reed is adjustable here. You can move it to either push past the North Pole or pull on the South Pole, but not one or the other. You can't put it into the neutral position. It does not want to operate there. So let's go over and have a look, and I'll explain all this to you. Okay, I got a little bit disturbed here because the battery went dead, so I had to change it. But what I want to do is explain to you that if you look at this motor and you look at where the reed is here, you can see that it fires when the magnets pass the center of this coil. That means that this coil then, becoming north, pushes. So it's a pusher. If you look at the 8 inch and where the reed is on this one then becomes a pusher too, because it's firing just past the center of the coil. Now, on this one, this other 8 inch, we're looking at the coil being pulled in by this magnet. because it's just past the center of this one. So remember, it can only pull once it's past this reed, once the reed releases. Once that's done, because if you turn the reeds on, if you short this out, the magnets will all go directly center of these coils, which means it can't move any further. That's the zero neutral point of the magnetic field that's generated across these poles. This one here, if we look at it, is a pusher. It's pushing. And this one here is pulling, because the reed is up towards the center of the coil here. So you can see what the difference is in all the motors and why I was doing this experiment, because I wanted to know if it actually was a push-pull motor, which it's not, in my opinion, because it wouldn't work that way. Anyway, that's the wave shape coming from this big 8-inch over here. And so you can see the voltage spikes are about 5 times the battery voltage. And you can see it switching on and generating the AC wave in between. So this type motor might work very well with Dad Halves 2-transistor circuit, if you can get it, the bias correctly on his circuit, which seems to be a little work to do it. Anyway, I can explain it to you on this piece of paper. You have a north pole here and a south pole here. So, if the reed is here, then it pushes to this neutral point, and that's it. The reed's off by then, and so nothing's pulling that magnet in here. And that's just the way it works, guys. There's no other way it works. You have a neutral point in the center of the coil, and you have a neutral point in between these magnetic fields, which nothing can happen. It's almost like a flux motor. And so the idea is that if you wanted it to push-pull, you'd have to do an arrangement sort of like this, where this is past this, pushes the reed on, and then this one's pulling in at the same time this one's pushing out, and then you have a push-pull motor. And you can do it with this arrangement if you change these poles and you change a little bit about the rotor. Otherwise, it's either a pusher or a puller. And the reason that it works so well at such low currents is because it's on these needle bearings. You know, they're in a jeweled bearing or a brass bearing. Some of these are in brass bearings, some are in jeweled bearings. This one happens to be in brass bearings and is working pretty good. The other thing is, make sure that you get these. You can see this one wobbling a little bit. I stuck the pin through and it was off. And this one's pretty straight and runs very well. These have been running ever since I posted what I was going to build on the group. And so I wanted to share a little bit about this with you. And if I can answer any questions, I'll do that. But anyway, I wanted to give you an update on what I was doing and what I'm looking at. So I like to study things to the fullest. And that way I get an understanding of what's actually going on before I decide to build something. Now, if we were going to take and arrange the coil like this, and one down here like this, and we made this a north pole, and this a south pole. Okay, we could build a neutral motor. We could actually fire it so it come in here like this, And actually the rotor would be, the timing would be at 90 degrees from this. So the pole would want to go from this point to this point, and this point to this point. So your coil would be actually this way. And then you would have a zero force, what we call the zero force motor. And that's the only other way to do it. Then, you know, you'd have a 2-pole rotor, or 4 poles. But it's very important on the spacing of these magnets, because if you get them too close, you're going to end up with it going to the neutral point and just sticking there, which would be this point right here. So just remember, if the reed's over on this side and it triggers, if the magnet's being sucked into the South Pole. You see? But the other magnet's far enough away so that it's not being affected by this North Pole, otherwise it'd be pushing backwards and end up in the center again. So anyway, that's where I'm going with this. I'm working on a completely different concept. I'm studying the bearings and what can be actually done with this motor. And then I'm going to work on the recharge and the battery for it, which I'm going to 3D print, which I already know exactly how I'm going to do it and what filaments I'm going to use to do it. So anyway, I'm going to share this with you, and I think that I've shown you why I've been so busy and off the group. Okay, first of all, this is my arrangement of monopoles. And some are pushers and some are pullers. And I'm going to explain something to you now, and then we'll have another look. Oh, and the other thing that I wanted to tell you here about these motors is that Tom Childs Teslagenics has been working on this with me for quite a while now, and that company right there will make the 3D parts available as soon as I finalize exactly what I'm going to do. I think that the easiest one to work on would be this big one, which would be the 8-inch one. That's the maximum my printer can do, the Robo, is this 8-inch stator and rotor. And the smaller ones are a little bit harder to work on, because you have to be much finer wire. I've found that these coils here with number 30 gauge are really easy to work on, and the impedance is just right when you get them laid out like this at over 3,500 turns on each coil. And this is number 32, and this is number 35, and of course this is number 36 here. And so I thought I would share this with you. But remember that your moderator, you know, Tom Childs, is working on this also, and that if you have any questions, you know, on the printing or anything like that, why, Tom would be the guy to ask. So one more look at the wave. And then another thing, too, I'm going to bring up is I think when I go to the next conference, I'm just going to sell these motors off there at the conference, and the monopoles that look like the Ferris wheel, because I put a lot of effort into this, and it's quite a costly endeavor. Anyway, so have a good day. Hope it helps you a little bit. Bye.